Hello everyone, and welcome to a webinar on the Lucy 3D stereotactic QA Phantom available from Standard Imaging. I have some slides that we'll be going through today, so feel free to ask any questions throughout the presentation with the chat box. You are all on mute-only mode, and if I don't see your question during the presentation, we will try to address it at the end. And I believe you will be receiving a recording of this webinar in your email afterwards as well. Today we will be discussing the requirements of TG142 style recommendations in regards to stereotactic QA processes, including the various methods, QA methods, and their impact on patient treatment, and what essential QA tests that can be performed using the Lucy Phantom, along with their tolerances and associated with the measured quantities. So this is the Lucy Phantom. It's an acrylic sphere that's 16 centimeters in diameter, and there are 0.1 millimeter machining tolerances in all of our regions of interest for the Phantom. The Lucy Phantom can work with all frame-based and frameless stereotactic systems with a fairly easy assembly process that includes attaching the Phantom to whatever frame or frameless system you are working with. So if we think about TG142 and the plethora of tests that are associated with each modality, there are a few standout tests that the Lucy Phantom can integrate to create a comprehensive QA program for your SRS procedures. For example, as shown on this table here, we have the mechanical and dosimetry aspects of monthly tests, such as laser localization and output or dose verification. And similarly, and more applicable to the Lucy Phantom, are the annual SRS requirements as outlined in Table 3 of TG142, where a rigorous study of all the mechanical elements, basically anything that moves, needs to be investigated, along with the various aspects surrounding dosimetry for any given SRS plan. And of course, the Lucy Phantom can assist us with all of these tasks. In addition to the Linux-based SRS QA tasks, there are also several imaging QA requirements that the Lucy Phantom is equipped to handle as well. For example, the Lucy Phantom has specialized inserts for analyzing many of the image quality parameters for both CT and MRI-based planning images, along with assessing the image localization for daily verification of patient position. So before we talk about specifics on the Lucy Phantom, I really just want to show an image of a screenshot here from a treatment plan to get everyone on the same page of the fact that we are looking at some very high dose delivery techniques that need to be highly precise. This is a very high precision therapy mode, and that's always something to keep in mind when we're going through our SRS QA procedures or measurements or tasks. We have millimeter-sized targets that require a higher level of scrutiny. And with the Lucy Phantom, we can achieve these objectives. However, it's always good to ask questions along the process and make sure you understand the results that you've obtained and whether or not they actually make sense. So the Lucy Phantom, as we discussed, is based on the acrylic sphere, and there are specialized inserts that are switched in and out of the Phantom to test all the various parameters associated with SRS techniques, resulting in a true end-to-end testing tool. The inserts shown here are on the upper left-hand corner, starting and then going clockwise, as the electron density insert, going counterclockwise, an ion chamber insert, CT inserts, including our spatial distortion grid, our markers. We have an irregular volume-shaped insert down there on the bottom, as well as our MRI, on the bottom right there is the organ at risk insert, so we can rigorously test the treatment planning system. And we'll talk about each of these in specific as we go through here. So to begin, I want to talk a little bit about the imaging side of things, and then we'll talk about the dosimetry aspects. The Lucy QA Phantom can, of course, help us with our CT dosimetry characteristics, so we can look at the CT linearity and uniformity of the CT numbers with the electron density QA insert where we would image the phantom, contour our various regions of interest, and then use our region of interest software to determine the measured CT values compared with our nominal values established during commissioning of the machine or when it was last recalibrated. Now, tolerance for this is a baseline level, and CT numbers are often quite variable, and sometimes we don't even have control over tuning the CT scanners. So as long as they are within about 10% of your nominal value as established on the scanner, I would accept that, and maybe go back and look if you'd like a second assessment, or change your ROI size as well. So another factor that the Lucy Phantom can look at on the imaging side of things is image distortion with both CT and MRI. And this is the CT grid, where we can look at any facial distortion, where you, again, take an image and then use your measurement tool to determine the potential distortion of the image geometrically, comparing your measured distances and grid size with the known and very well machined grid. Again, not shown here, this similar type measurement can be performed in 3D on an MRI image as well. The tolerance for this test is typically given to be 1 millimeter or less, and I will mention that most of the clinical information in this presentation has come graciously from one of our Lucy users, Dr. Anil Sethi down in Chicago. So a lot of the tolerances that I'm quoting here are the clinical tolerances that he uses in his program. They may or may not be applicable to your program, but it's at least a good starting point for us to go from. So we can also look at image segmentation, so comparing known volumes with volumes that are measured on a CT or MRI image using that same electron density insert. Here we have a table comparing our measured and calculated volumes for each of those ROIs, and within about 3% is what we would like to be. So after analyzing the imaging capabilities of our CT or MRI system, the Lucy Phantom can also look at your Fusion QA. So if you have Fusion software or Fusion routines within your treatment planning system, we can take two different CT images, one that's slightly rotated, for example, and compare those within your Fusion QA software routines, looking at how well the structures are aligned. This is just a screenshot showing a CT MRI Fusion QA. So in the top left, we've got our MRI image of the Lucy Phantom with that irregular ROI, and a CT image as well, showing the mapping of those two. For some quantitative information on our Fusion results, here in this table, we've compared a 45-degree rotation between two different CTs of the Lucy Phantom, same imaging parameters, just rotated a little bit. And looking at the CT markers within the Lucy Phantom, we can see that this particular image fusion worked very well, where our predicted error between the two image sets after alignment, checking those various different marker points, the coordinates are all within about 0.5 millimeter of each other, which is an excellent CT to CT fusion result. I would accept that, and then move on to our next task. Similar rotations can, of course, be performed with a CT to MRI, making sure our coordinate systems and rotations there as well. Comparing a CT to MR, the tolerances or the measured deviation between our initial image and rotated image was around 1 millimeter. And going between imaging modalities, I would accept that as well, being acceptable within about 2 millimeters to our CT to MRI type fusions. And that's just one aspect of the process, as we all know. So after we've established our baseline and organized the imaging and image fusion capabilities of our SRS program, the next step would then be to move on and look at the planning system itself. So the Lucy Phantom has a very nice insert. It's called an irregular shape or OAR type insert, where we've got a target and then an organic risk right next to that target. And the goal of this test is to really look at how well your treatment planning system can contour those volumes. You can look at the measured volumes after you've contoured versus the known volumes, but then also how well does the dose conform to that particular target, accounting for that organ of risk right next to it. And for a particular example planning case, this one, if we assume a spine case, we know from experience that we have about a 5 to 10% millimeter, or 5 to 10% per millimeter dose drop-off as you go away from your target and your actual dose delivery area. So knowing that, you can then go on and apply that type knowledge in our clinical use as well. So after you've used the Lucy Phantom with this type of insert and assess what your dose drop-off is like, you can get a better assessment of what your margin should be, for example, and how well you can actually account for organ shifting or shrinking, changing shape, or whatever. And this particular clinic uses a tolerance of 3% regarding how well the dose is conformed to our target and compared with the organ at risk right next to it. So after the planning type information gets organized and applied, the next step that I would consider is our image verification. So image verification on a daily basis, for example, I'll turn down the microphone here. The Lucy Phantom can also help us with our daily image verification. In particular, this example uses the Variant OBI system and BrainLab Exact Track daily verification, but any daily imaging verification process can be assessed with the Lucy Phantom. So to check our daily imaging positioning process, you would set up the Lucy Phantom on your treatment couch and then simulate or apply a known shift and compare that with the IGRT system predicted shift. Looking at the image fusion using those markers within the Lucy Phantom, and we typically like our image fusion for a daily basis to be within around a millimeter. So in addition to verifying the patient positioning process, we also want to measure our dose delivery process too, so a true assessment of the planned dose versus our delivered dose. We can look at that using a variety of different dosimeters, including an ion chamber or film. Oops. And typically, we want to be within 2% to 2 millimeters with a 95% passing rate. In addition to a just point measurement of planned versus measured, we can look at the MU check as well as your IMRT type plans as well. So a conformal delivery, again measuring with an ion chamber or a film. Overall, if we look at the Lucy Phantom, the process QA is what's our main focus, where we can look at the scan parameters, our planning parameters, how well do we treat or deliver the dose, and then verify it based on our measured values. The Winston-Lutz type test is another method to test this whole process, whereby we've got a hidden target shown by this small BB insert here. And that's imaged, that's planned on, and then that's delivered using your treatment planning system and daily image verification and a measurement at the end, giving us a true end-to-end style test of your SRS-QA process. And this is above and beyond testing each one of those steps. So Lucy Phantom is very nice in that we can test each of the aspects individually, but then we can also look at the whole process too, whereby we check our positioning, we check the dose, point dose, and then we can look at the dose distribution as well. The used tolerances, or the tolerances used with Dr. Seth's clinic for this end-to-end test are shown here, mostly within 2%, 2 millimeters for things like our dose distribution, which is a commonly known or applied SRS dose tolerance level. For a frame-based style test, we also have the capabilities of doing that hidden target test within the frame. So you would set up whatever you normally use for your treatment planning or for your treatment delivery process, be it frame or frameless, using that hidden target Winston-Lutz type test within the same setup, and then comparing that hidden target Winston-Lutz style test results with something like this Pro software. Is a very easy to do process just by acquiring the necessary images at the various different gantry angles or planned angles, and then analyzing within the HIPS Pro software. We can also look at the hidden target alignment and fusion or alignment and shifts using the FrameLab software as well. It's just an example of using that hidden target to assess your image fusion software. So overall, the Lucy Phantom is a truly comprehensive SRS QA tool, and there are a variety of different inserts that once you really sit down and look at your QA program and what instrumentation you're using and what tests you need to perform, you can really tailor which inserts you need for the Lucy Phantom. Some clinics don't have an MRI, so they don't obviously need to purchase the MRI insert. Similarly, if you don't have access to film anymore, obviously we'll look at diodes or ion chambers to perform your dosimetry measurements. So we can really work together with you and help you tailor the Lucy Phantom to fit your program specifically, and then go through and set up what tests need to be performed, what inserts need to be used, and determine really what tolerances you should be looking at each step, and then also with that complete end-to-end test at the end of your commissioning or QA process as well. The Lucy Phantom, after the initial learning what inserts go where, is very friendly to the user and quite fast to set up. And it's very flexible, as I just described as well, where we can work with all of the frame or frameless systems or the image registration systems as well, and scanning systems. So with that, I would like to say thank you, and again acknowledge Dr. Anil Sethi for a lot of the slide material here for the clinical use of the Lucy Phantom. And if you have any questions, feel free to type them into the chat window here, or contact your sales rep at Standard Imaging for more information on the Lucy Phantom. All right, it doesn't look like there's any questions for us today. I encourage you to email your sales rep if you do have another question, and they can also get a hold of me as well. Oh, there's one question. Hold on. So, there's a question regarding CyberKnife film-based end-to-end, and unfortunately, we do not have a CyberKnife specific film insert. So I don't think that would be a straightforward application for the CyberKnife machine itself. I know that there's the end-to-end CyberKnife QA process that they have, but we don't have anything specific with the Lucy Phantom that would help you with the CyberKnife. And I should mention that we do have a forthcoming project for the CyberKnife, though, that will focus on a filmless solution for your daily QA for the CyberKnife. So I would watch your inbox for information on that product as well. There's another question, are there any film inserts at all? Yes, we have a variety of different film inserts. A single film insert, so I think it was shown in the presentation where there's a single milled out region where you can put a central 4 centimeter by 4 centimeter piece of film. But we also do have a stacked film insert, so you can stack up to 14 pieces of film, each with spacers and markers on those spacers to get your orientation information within that stack of film. And that stack of film, I believe, is around 3.5 cm tall, so we can get a nice assessment of a relatively clinically relevant region for a 3D type assessment. Obviously, you want to mark your pieces of film above and beyond the one that gets marked with the Lucy Phantom inserts. I would go ahead and mark each of my films so I know which one is which within that distribution. So there's a question here about the Lucy QA Phantom being used for patient-specific SBRT QA. I don't have any specific patient-specific information that I can share with you, but I can get you a few names of our clinical users, as I'm sure that they've looked at either doing film measurements or ion chamber measurements to check a plan, but I personally don't have any names or an example to show you in a slide. But I can definitely get you the information of clinical users, and they can share with you what they do, be it TLDs or ion chambers or film. All right, I think I will go ahead and end our session today. And again, feel free to email with any questions. I'll type my email address down here since I don't think it's shown on the screen anymore. And you can contact me or your sales rep for more specific information.